Okay, so now what I want to show you is how you can calculate the correlation coefficient using a spreadsheet. I've shared this folder with you, and you'll see in chapter 3 there's a 3.1 linear correlation. So when you open this up, going through your workbook, you're going to be able to access a bunch of these statistics. It's nice because you don't have to do any of the inputting, and it's current. Well, it's pretty current, but it's real life stuff, so you'll get to practice doing some actual math. So if you click on baseball homers, it's going to open up this spreadsheet for you, and it's a comparison of the New York Yankees. It's a couple years ago because you can see Melky Cabrera is playing for them. He's now with the Blue Jays after the San Francisco Giants and of course his suspension for steroids, but that's another topic. And at the bottom you've got the Baltimore Orioles. So it's a ton of data, but what I want to show you is how you can calculate correlation between two sets of data. So we're going to look at games and at-bats to start. So in any open cell, if you type in the equal sign and just take a guess, correlation, there it is. So it says it returns the correlation between data, two sets. Data 1 is the first set, and data 2 is the second set. So you can hit enter. The first set we want is games, so you can go ahead and highlight games. Down to there, comma space, and the second set is at bats. I'll close it with the bracket and I'll hit enter. Now I've got to scroll back up. There's the correlation between games and at bats. That's extremely strong. It's very close to 1, and that makes sense. The more games you have, the more at bats you're going to get. In any given game you may get 3 or 4 at bats. But the question I want to ask you is maybe what's the correlation between games and average? Is it going to be as strong as games and at bats? Well, it's real simple to calculate. We don't have to worry about that formula. We can just use our correlation formula again. I'll go games as my first set of data, comma space, and sort this time average as my second set of data. Close the brackets and we'll see. And you can see it's not even close. So there's a 0.53 correlation value between games and average, which I think makes sense because just because you get an at bat doesn't mean you're going to hit it. So in this our value here, perfectly correlated, pretty close. This is going to be a moderate positive correlation. And that's as simple as it is. You can do this between any of the data sets. You can find the correlation and you don't have to ever touch that formula. You've used these pretty extensively, I believe, so you should have no problem inputting data. But just in case we forget, you're going to click on the stat button and you're going to click on edit and it'll give you this list. I've already gone and inputted the data. It's the exact same data that you just saw. So you'll have to go in and input it into L1 and L2. And then in order to actually run any type of correlation, we go back into stat. This time we go over to calc. And you can see number 4, linear regression. We're going to scroll down to linear regression. We'll hit enter. It tells you your X list is L1, your Y list is L2. That's what we want. So we will cursor down to calculate and hit enter. And lo and behold, here it is. This is grade 9 math, y equals mx plus b. It gives you the equation of the line if you want, but it also gives you this r value. And you can see it's 0.97, which was exactly the same as what we got using the spreadsheet. So that's the simple way to find it. This class isn't focused on actually computing the R value. It's about understanding what it means, knowing how to use it, and interpreting the data when it's given to you. So this is just a shortcut for you to use. Before we move on though, I do want to show you 2 other features of the calculator. So if I go back into stat and go to calc, I've got these first 2 options, 1 variable stats and 2 variable stats. Let's start with the 1 variable stats. It automatically defaults to L1, and that's fine for us. If you remember, L1 was just the number of games that the player had played. Let's click calculate and it kicks you out a ton of values. So here's your mean, so you don't have to add it up and divide, it just automatically does it for you. Here's your standard deviation, which we worked with and we calculated by hand. That tells you that the standard deviation is quite large, so a player could play 70 games plus 58, 70 games minus 58. So you're looking at a range of 120 games for your standard deviation, which means that the mean isn't that strong. It also gives you, and I think this is the best feature, it gives you your quartile ranges. So it gives you your minimum X, your maximum X, your median, your Q1, your first quartile, and your Q3. So there's your interquartile range. So here's your box and whisker plot right there done for you on the calculator. No need to do any computations whatsoever. One last thing, if we go back into calc and go down to two variable statistics, it will do L1 and L2 now for you because you're looking at both variables. Click enter, and again it will give you all of that same information. It tells you how many data sets there are. There's 22 there, but it also gives you standard deviation of your Y value, which we haven't done yet, but that may be something you're interested in. Minimum, maximum, gives you your ranges. So don't forget that that's there. Feel free to use these calculators to their advantage. They're very powerful. Okay, that's it for now.